Welcome back to another interesting video of Maths and Olympiad. In this video, I am going to take up a very nice algebra question from Maths Olympiad, which says 8 raised to the power x plus 27 raised to the power x over 12 raised to the power x plus 18 raised to the power x equal to 7 over 6. I will do the substitution twice in the question. So it would be a nice learning video for all of you. So let's start by writing the solution. Now we can express 8 as 2 raised to the power 3 whole raised to the power x plus 27. We can write it as 3 raised to the power 3 whole raised to the power x over. We can find out the factors of 12. Similarly 18. So we can write 12 as 2 raised to the power 2 times 3 whole raised to the power x plus 3 raised to the power 2 times 2 whole raised to the power x equal to 7 over 6. Now I will use an exponential property which says a times b whole raised to the power m is equal to 8 raised to the power m into b raised to the power m. So I will write the numerator as it is. Now in the denominator we can use this property. So we can write 2 raised to the power 2 whole raised to the power x times 3 raised to the power x plus 3 raised to the power 2 whole raised to the power x times 2 raised to the power x equal to 7 over 6. Now I will use another exponential property which says a raised to the power m whole raised to the power n is equal to a raised to the power n whole raised to the power n. Here we have interchanged the exponents. So we can write it as 2 raised to the power x whole raised to the power 3 plus 3 raised to the power x whole raised to the power 3 over 2 raised to the power x whole raised to the power 2 times 3 raised to the power x plus, here we can write 3 raised to the power x whole raised to the power 2 times 2 raised to the power x equal to 7 over 6. Now we have common terms 2 raised to the power x and 3 raised to the power x in the numerator as well as in the denominator. So we will do the supposition here. Let 2 raised to the power x equal to m and 3 raised to the power x equal to n. So I can write in the numerator m raised to the power 3 plus n raised to the power 3 over, here I can write m raised to the power 2 times n plus n raised to the power 2 times m equal to 7 over 6. I will write it as m cube plus n cube over m square times n plus n square times m equal to 7 over 6. Now I will use the algebraic identity a cube plus b cube in the numerator, which says a plus b times a square plus b square minus a b. So I can write m plus n times m square plus n square minus m times n over m square n plus n square m equal to 7 over 6. I will write the numerator as it is. If you see in the denominator, we have a common factor m times n. So we can write it as m plus n equal to 7 over 6. Now m plus n will cancel out m plus n. So we are left with m square plus n square minus mn over m times n equal to 7 over 6. Now I will do the cross multiplication. So it will become 6m square plus 6n square minus 6m times n equal to 7 times mn. Now I will shift 7 times mn to the left hand side. So it will become 6m square plus 6n square minus 6 times mn minus 7 times mn equal to 0. Now in order to simplify the equation, I will divide both sides by m times n. Now this means that mn will divide each of the terms in the numerator. So it will become 6m over n plus 6n over m minus 13 equal to 0. Now I will do the supposition again in order to simplify the equation. Let m over n equal to a. This implies that n over m will be equal to 1 over a. So the above equation will become 6 times a plus 6 times 1 over a minus 13 equal to 0. Now this is a linear equation in one variable. I will take LCM. So this will become 6 times a square plus 6 minus 13 times a equal to 0. So our final equation will be 6a square minus 13a plus 6 equal to 0. This is a quadratic equation in terms of a. We will use the splitting the middle term method to solve this equation. We will split minus 13a into minus 9a and minus 4a. From these two terms, we have a common factor 3a. From these two terms, we can take out minus 2 as a common factor. Again, we have a common factor 2a minus 3. I am taking it out. This implies 2a minus 3 equal to 0 or 3a minus 2 equal to 0. So we have got a equal to 3 over 2 or 3 is equal to 2, a equal to 2 over 3. So we have got two values of a, 3 over 2 and 2 over 3. So let's take when a equal to 3 over 2. Now let's recall a equal to m over n, and m is equal to 2 raised to the power x and n is equal to 3 raised to the power x. So in place of m, I can write 2 raised to the power x over 3 raised to the power x. This implies a equal to 2 raised to the power x over 3 raised to the power x. Now in place of a, I can substitute the value of a, which is 3 over 2. I will write 2 raised to the power x over 3 raised to the power x on the left hand side and 3 over 2 on the right hand side. I will use another exponential law which says a raised to the power m over b raised to the power m equal to a over b whole raised to the power m. So I can write 2 over 3 whole raised to the power x using the exponential law equal to 3 over 2. Now I have to make both the bases same, so I will write 2 over 3 whole raised to the x as it is, and I will write 2 over 3 whole raised to the power minus 1. I have used an exponential law which says a over b equal to b over a whole raised to the power minus 1. Now, since bases are same, we can equate the powers. A raised to the b equal to a raised to the c. This implies b equal to c. So here we can write x equal to minus 1. So we have got our first solution. Now let's take up case 2. When a equal to 2 over 3, a equal to m over n, which is further equal to 2 raised to the power x over 3 raised to the power x. So I can write 2 over 3 equal to 2 over 3 whole raised to the power x. Since again bases are same, so we can equate the powers. This implies x equal to 1. So we have got our second solution. So in total we have two solutions for x equal to 1 and x equal to minus 1. I hope you will like this video, and please don't forget to like, share and subscribe. Thank you.